This is Math 1710, Section 6.2 on ellipses. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is fixed or constant, with each fixed point called a focus. And of course, the plural focus is foci. You can see in your notes that ellipses are kind of like oval shaped. Some of them are have a horizontal long axis, and some of them have a vertical long axis. At the bottom of page 55, you will also see that sometimes the ellipse is translated away from the origin, just like parabolas and other conic sections. And again, it can apply to horizontal or vertical shifting. So a conic, again, is a set of all points in a plane so that the ratio of the distance from P to a fixed point, the distance P to a fixed line, is constant. The line is the directrix, the fixed point is the focus. Now what I'm going to do is work some examples from this section. So the first example is to graph 4x squared plus 9y squared equals 36. You will see in your notes that this is not in standard form because x squared and y squared are alone in the numerators. But what I'm going to do is divide all my terms by the LCD of 4, 9, and 36, which is 36. So I'll divide by 36 on all my terms, and that'll give me x squared over 9 plus y squared over 6, or 4 rather, and that'll equal 1. Now, whichever number is larger, which in this case is the 9, the fact that it's under the x squared term, that means the x-axis is going to be the major axis, the longer axis. So here A is going to be 3 and B is going to be 2. So that gives us x-intercepts of 3 and 0 and negative 3 and 0, 3 spaces on either side of the origin. And the y-intercepts are 2 spaces on either side of the origin, so that gives us 0 and 2 and 0 and negative 2. We also need to calculate the value of c, which in your note says that c squared is a squared minus b squared. So c squared is going to be 9 minus 4, which is 5. So c is the square root of 5, which is 2.23, just to give you an idea of how far away from the origin it is located. So the foci are square root of 5 and 0 and negative square root of 5 and 0, based on the square root of 5 for the value of c. So when we graph it, we do the intercepts, 3 and 0, negative 3 and 0, 0 and 2, and 0 and negative 2, and the foci 2.23 would be about right there, and about right there, I'm sorry, right here, and about right there. So our graph would look like this. All right, I'm going to do another example where I know the center of the ellipse is 0, 0. The foci are 0 and 3 and 0 and negative 3. And that tells me that C is plus or minus 3. So that means C squared is 9. The major axis, we're told, is 8 units long for the major axis. Now, on either side of the origin, that means you have 4 spaces. So A is 4, and A squared, of course, would be 16. So we're going to now, we know C and we know A, we're going to find B. So C squared equals A squared minus B squared. So 9 equals 16 minus B squared. If you subtract 16 from both sides, you get negative 7 equals negative B squared, or B squared is equal to 7, and B is equal to square root of 7, which is 2.65. Okay? And what we're asked to do in this example is to write the equation based on the original information that we had up here at the top. So the equation is x squared over b squared plus y squared over a squared. So that's x squared over 7 plus y squared over 16. Of course, that equals 1, and this equals 1. So there's the equation based on the original information that we had up there at the top. All right, I'm going to do a third example now. Example 3, I'm going to graph another ellipse, x minus 2 parentheses squared over 9 plus y plus 1 parentheses squared over 16. If you'll notice, it's not just x squared and y squared. There's other numbers in the parentheses, so that means the ellipse is shifted away from the origin. So we're also told that the center of it is 2 and negative 1. And that's based on the fact that it's the opposite of negative 2 and the opposite of plus 1. A is 16 because A is always the larger number. A squared is 16, so A is 4. B squared is 9, so B is 3. So we can, this C right here stands for center, not the C that I'm going to look at right now. C squared equals A squared minus B squared. This C is the foci, this is the center. So C squared equals 16 minus 9, which is 7. So C is the square root of 7, which again is 2.65. So we're going to do our graphing here. The center is 2 and negative 1. So there's the center. On the y-axis, we're going to go 4 spaces in each direction. 1, 2, 3, 4. So that'll put an point there. We got 1, 2, 3, 4 in this direction. I'm sorry, that was on the x-axis. I should have done 3 instead of 4. So it'd be right here and right here. And on the y-axis, 4 spaces. 1, 2, 3, 4. And down this way, 1, 2, 3, 4. So there's my other point. So my ellipse will look like this. This would be 2 and 3. This would be 5 and -1. This will be 2 and -5. And this would be -1 and -1. So you start from the center, you count 3 left and right and 4 up and down. And that's how you do your graphing on this one. The last example talks about something called eccentricity, which is really not mentioned in the notes, but it's denoted by the letter E. And we're going to find the eccentricity of x squared over 9 plus y squared over 16 equals 1. So a squared, the larger numbers, always a squared, so that's 16, so a is 4. B squared is 9, so b is 3. So that means that the vertical axis is the major axis. We also need to find c squared, which is a squared minus b squared. So that's c squared equals 16 minus 9, which is 7. So c is the square root of 7, which is 2.65. The eccentricity, E, is equal to c over a. Very simple little formula. C is the square root of 7. A was 4. When we calculate this, we can do that on the calculator. 0.66 is the eccentricity. That completes this section.